Hi everyone, welcome to my channel. I've been experimenting with this relay module. It has 4 mechanical relays on it and 4 surface mount LEDs that light up indicating when the relay is activated. It didn't come with any documentation though. Would have been nice to have some documentation. It does seem straightforward. It has this male header here and it's labeled VCC. And there's in 1, in 2, in 3, in 4, and then a ground connection. And there's a jumper here. Looks like that's for VCC. You have to have that jumper on. And it has a terminal block on the other side here to make your connections to the relays. So you have a center or a common, and one side is normally open and the other side is normally closed. So it seems to be pretty nice quality. It's pretty thick PC board. You can see the other side here where the relay and the header pins come through, and it has a lot of surface mount components also. This is where you really can start to use the power of a microcontroller. Instead of just controlling LEDs on and off, you can start controlling some pretty powerful appliances or motors or just large current and large voltage devices. We can zoom in here, take a look at some of the specs on these relays. So you can see the specs right here on the relay itself. There are 2 for AC and 2 for DC. And they have a C here, so this says it's form C. I downloaded the specs off the internet. Take a look at those. So here's the device here. So you can see here they have a block diagram. You've got 3 contacts that are brought out to the terminal block. So you have the center, and then you have the 2, and one is normally closed and the other side is normally open. And then when you activate this coil in here, it throws this relay and closes the normally open side. So now you have the contact between these 2, and then this one is now open. And we have 7 amps at 28 volts DC, 10 amps at 125 volts AC, or 7 amps at 240 volts AC. Now I don't know exactly about this inductive load. They have 3 amps at 120 volts AC or 3 amps at 28 volts AC. If anyone has more information on that, leave that information in one of the comments. But I'm not certain what distinguishes this contact capacity from the inductive load specs. So essentially those 3 contacts, like I said, are brought out to the terminal blocks, and you've got a normally closed between 2 contacts, and then the other 2 contacts are normally open. And then when the relay is energized, this switches over and closes the normally open and opens the normally closed. So I was thinking about how to go about exercising these relays, and then I thought about that Knight Rider sketch where we use the shift register to scan the LEDs. And what we did is we created an array with decimal numbers, but the equivalent binary would light up the LED in the right sequence as we step through the elements in this array. But in this case, I only have the 4 relays. I don't have, instead of the 8 LEDs. So I just cut down all these elements down to 1, 2, 4, and 8. And then we were not going to step through 14 elements anymore. That was just going to be 4 elements. So I just changed that and loaded the program. So I loaded the sketch, and this is what I ended up with. And I immediately noticed I have a problem. I have 3 relays on at a time. So I scratched my head for a second, and then it dawned on me that I can't just use an abbreviated version of that Knight Rider sketch. And this is the reason. Let me show you on the whiteboard here. So this worked with the LEDs because the output of the shift register is hooked up to the anode of the LED. So when it produces a logic high or plus 5 volts, it turns on the LED. But the relays on that relay module are active low. So wherever there was a 0, it would turn on the relay, and wherever there's a 1, that relay is off. So the first thing that came to mind to solve that problem was to put a hex inverter on the outputs of the shift register to invert the signal. So here I have a 7404. So if we turn this on again, you can see I have 3 relays on at any given time and 1 off. So now what I want to do is go from the output of the shift register into 4 inverters on this 7404. So let me connect these wires up. So this is the A output on the shift register, and this is the first inverter output right there. This is the B output on the shift register, and this is the second inverter output right here. This is the C output from the shift register, and that goes to the third inverter there, and the fourth inverter output here is pin 8. So let me turn that on again, and you can see now that I've inverted the signals. I have 1 relay going on at a time. So I was feeling pretty good about this solution, and then it dawned on me that there's a software solution. You don't need to include the 7404 hex inverters. Let me show you why. So the original elements in the array 1, 2, 4, and 8 work great when you want to turn on the LEDs, but because the relays are active low, 3 relays at a time get turned on. So all you need to do is change that so the numbers are now 14, 13, 11, and 7, and their binary equivalent ends up having 1s in these positions and only a 0, 1 at a time. So you have the 3 relays off at a time and only 1 on at a time. And that was the software solution that would have saved a lot of time. So I just added or changed the sketch. So the elements are now 14, 13, 11, and 7. So I've already loaded the new sketch, but you'll see we're right back to square one because I have the inverter now. So we have the correct logic levels coming out of the shift register, but I'm inverting them, so we're back to the problem we had with the first sketch, where we have 3 relays on at a time. So now I can do without the hex inverter chip. Let me turn this off and put the wires back to where they were. So let's see, this one went here, that's C. So I have the 7404 out of the circuit, and I have the wires going directly to the shift register. I've got the new sketch in with the new elements. And let's turn this on. So you can see now I have 1 relay being turned on at a time instead of 3. So that's the software solution. So that shows you how you can use the Arduino to control relays, and how sometimes a problem can have both a hardware and a software solution. In this case, the software solution obviously was a lot easier. So I hope you found this video interesting. Please Please subscribe, like, and or comment. And thanks for watching. Oh, look at that. At first I thought I had a problem. Then I realized I bet this 9-volt battery is running low. It's a rechargeable in here. And it just has enough to now just change the LEDs, but not enough to activate the relays.